right, guys, let's get into 1.7, which is the last section here in Chapter 1 on midpoints and bisectors. Two words that you probably haven't heard in a math class before, but I'm betting if I asked you to, you could think about those for a minute and kind of try to figure out what they are. So the first thing we're going to do here, guys, is write down a definition for what we mean by a midpoint. Okay? And so, as the name kind of suggests, kind of tells you what it is, a midpoint is a point in the middle of a line segment. So our definition right here formally is that the midpoint is the point halfway between the endpoints of the line segment. So in this little diagram I drew here, I drew our line segment YZ, which starts right here at Y, ends right here at Z. Those are your two endpoints. And then I just tried to eyeball where I should put point M so that it was directly halfway in between those two endpoints. I think you guys can tell that if I moved point M here, that's not very good. That looks like M is much closer to Y than it was to Z. And likewise, if I put M over here, now I got the opposite problem. M is much closer to Z than it is to Y, so we want M to be as close as possible to be directly halfway in between Y and Z. However, we should actually use some notation, some shortcuts here that we talked about earlier in the chapter. You're not allowed to assume from a diagram that M is a midpoint of a line segment just because it looks close. Not unless I either told you in the directions that it was, or we used a trick we learned, I think, in section 1.3, which would be tick marks. If I were to put a double tick mark here on YM and then the same number of tick marks here on MZ, that would tell you now that line segment YM is congruent to line segment MZ. And now, since all three of those points are collinear, that now tells you this statement right here, that point M is the midpoint of line segment YZ. So following this definition right here, that means that M is the point halfway between Y and Z. Now, two more little bits of vocab you guys are going to need to know for your test in Chapter 1. It would also be true then to say that point M is equidistant from Y and Z. And as you might guess, that word right there, if we break it down, the equa means equal, the distant means distance. So equidistant means that something is equal distance from two other things here. So point M is equidistant from Y and Z because this distance right here is exactly the same as this distance right here. So that's what equidistant means. And the other thing we want to say, another vocabulary term I'd like you guys to get down, is the word bisect. Now, the prefix bi, B-I, means two. A sect, it's kind of like the word section. It means a part of something bigger. So what it means to bisect something is to cut into two congruent parts. Or to put it more simply, guys, to cut something directly in half. So that's what the word bisect means. There's a variation on that. To trisect something means to cut it into three equal parts. But bisect is what we use a lot more in geometry. So that's a little bit of vocab here at the beginning of this section. That tells you what a midpoint is. And please notice, a midpoint really only applies to a line segment. And then we talked about the word equidistant and the word bisect. Okay, we're going to talk about midpoints now in two different settings, just like we did with distance in 1.4. And the first thing we're going to talk about is the one-dimensional midpoint formula, which is what you do on a number line. Remember, guys, that a line is a one-dimensional geometric setting. An object can only move left or right, but it cannot move up or down, and it can't move in or out. It has no depth to it. And so your formula here, not even really much of a formula, M, which stands for midpoint, is equal to x sub 1 plus x sub 2, all divided by 2. Now, if that notation looks a little familiar, this is something we used with the distance formula back in section 1.4. x1 means your first x-coordinate, and x2 means your second x-coordinate. Now, there's no y1 or y2 here because we're on a number line, and a number line is one-dimensional, so you only need one number, an x-coordinate, to describe the location of a point on your line. The y-coordinate doesn't really exist here because we're in one-dimensional space. And what I want to make sure that everybody understands is you've been doing this for a long time, guys. When you take two numbers, x1 and x2, add them together, and then divide by 2, what you're really finding is the average of those two numbers right there, okay? So when we're finding a midpoint, it's really the point in the middle, and that's just the average of two numbers. Add them up and divide by 2. Let's see what we mean here. So in this problem here, I've gone ahead and I've drawn an entire number line, probably more than I needed to, and I've put 3 points on there, although I didn't center them very well. There would be point A, oh boy, there would be point B, all right, and point C I think was supposed to be right there. So I'm going to ask you guys now to use what we just talked about and try to find 3 different midpoints. First one, right here, the midpoint of line segment BC. So what did we just talk about, guys? Add together your 2 x coordinates and then divide by 2. So for BC, your first x coordinate is right here at 1, and we'll add to that your second x coordinate, that's 9, and divide all that by 2. Let's clean up the numerator first. 1 plus 9 is 10, and when we divide 10 by 2, we're going to get 5. So at the point 5 on the number line right there, my question for you guys would be, does that point look like it could be the midpoint of the line segment that goes from B to C? I think that one looks pretty good, so I feel okay about that answer. Let me switch colors now. I'll go green, and let's do the second question now. Midpoint of line segment AB. Okay, so your first x-coordinate is right here at A, which is -4, and we'll add that to the second x-coordinate of B, which is right here at 1, and we'll divide that by 2. -4 plus 1 is -3. Uh-oh, life just got difficult. And -3 divided by 2 is -1.5. Now, 2 questions probably occur to you right now. Is it okay for my answer to be negative? And is it okay for my answer to be a decimal? Well, let's look at the graph and see what we think. -1.5 is in between the integers of -1 and -2. So -1.5 is roughly right about there. So my question for you guys would be, does it appear that that green dot at -1.5 is equidistant from point A and from point B? It's not like a formal proof there, guys, but I feel pretty good about that answer right here. So yeah, what we did in number 2 there is correct. And let's do one more together right here. Feel free to pause the video if you want to try this one on your own. But number 3, midpoint of AC, which starts here at A, ends here at C. So x1, your left endpoint, is -4. We'll add to that x sub 2, your right endpoint, which is 9. We'll divide all that by 2. -4 plus 9 is going to give us 5, and 5 divided by 2 is 2.5, right between 2 and 3 right there. So does that distance appear to be equal to this distance right over here? Again, I feel pretty good about that answer. So yeah, positive 2.5 is our answer. So guys, that's how you do a midpoint on a number line. You're really just finding the average of your left endpoint and your right endpoint. So one-dimensional midpoints aren't that bad. Two-dimensional midpoints, then, is where we're going next, and this is just a little bit more complicated than what we did before, but you'll notice this part of the formula here is exactly the same. The only difference here, guys, is that in two-dimensional space, we're now on a coordinate plane, which has an x-axis, but it also has a y-axis. So your answer then needs to have 2 values, an x value and then a y value, separated by a comma with parentheses around the whole thing. Your answer here is going to be an ordered pair. All right, and the way you find your x coordinate is by taking the average of your x values. And then you follow that up by taking the average of your y values right here. y1 plus y2 divided by 2. So I'm hoping you guys realize that this is really the same formula as what we were doing just a minute ago with the one-dimensional midpoint. All right, we start off the exact same way. We just take that idea a step further and we put a y coordinate in there as well by taking the average of the y's. So let's see what that one might look like in practice. So we're going to find the midpoint of, forgot to move that, of line segment AB. There we go. If A is at the point 2, 3, and B is at the point 6, negative 5. Now, once again, when we're trying to learn a formula, make yourself write it out and say it out loud as much as you can. M is equal to x1 plus x2 all divided by 2. There's a comma in the middle of this formula because our answer will be an ordered pair. And then it's y1 plus y2 all divided by 2. All right, guys, let's fill in what we know. Midpoint is, and here we begin, x1, your first x coordinate here is going to be 2, plus x2, your second x coordinate, that's going to be 6. All divided by 2. Comma in the middle, and now on the right here. Y sub 1 means your first y coordinate here, which is 3. Plus y sub 2, your second y coordinate, which is negative 5. So it would be correct to write 3 plus negative 5. But you guys can maybe save yourself a little bit of time. Rather than adding a negative, you can just put a minus 5 right there, and that'll get you what you need a little bit faster. Again, all divided by 2. So a little bit of simplification right now. We'll go nice and slow. The first coordinate, its numerator, 2 plus 6 becomes 8. We'll divide that by 2 in a moment. And in the second one, 3 minus 5 is going to give us negative 2. We'll divide that by 2 as well. And all we have to do now, guys, is clean up this division. 8 divided by 2 is 4. Negative 2 divided by 2 is negative 1. And that looks like our answer. 4, negative 1. Now, great question, is it right? On the problems we were doing 2 slides ago, I was just kind of drawing the midpoints in the middle right now and asking you guys to see if you thought, hey, does that distance look the same as that distance? And we were just kind of eyeballing it. Let's try to do the same thing here. So I put a coordinate plane, further down than I needed to, way down at the bottom on this problem. And now, let me see if I can zoom in on this, and maybe we can figure out if our answer looks correct or not. I don't think it's going to guarantee it, but hopefully we'll be close. Let's see. A was the point 2, 3. So from the origin, I go right 2 up 3, and here would be point A. 2, 3. B is at the ordered pair 6, negative 5. So from the origin, I go right 6 units. 1, 2, 3, 4, 5, 6. And then 5 units down. 1, 2, 3, 4, 5 gets me to point B, which is located right here. Now there is one and only one line segment that connects A and B, and it would look something like that. And now we think we've located the midpoint right here. So let me plot the point 4, negative 1 and see what we think. From the origin, from right here, I'm going 4 units to the right, down 1 unit, and that gets me to a point right over here, and I'll call that M for my midpoint. Now, 2 things had better work out. First of all, M had better be on line segment AB. They need to all be collinear for this to work, and it looks like it is. And second of all, maybe more importantly, does it look like line segment AM is congruent to line segment MB? And I feel pretty good about that looking at it here with my graph on the coordinate plane. So the graph doesn't really prove that we got it right, but it does kind of point you in the right direction and say, hey, I think things are looking pretty good right here. So that's how we use the midpoint formula to find a midpoint in 2-dimensional space given your 2 endpoints. Let's try that same thing again here. Find the coordinates of the midpoint y of line segment xz given the coordinates of x and the coordinates of z. And again, those are the endpoints of your line segment. All right, that'll become more important on the next problem. So this is really the same problem that we just did. All right, our midpoint m is equal to, here goes, x1 plus x2 all divided by 2, comma. And then our y-coordinate is given to us by y1 plus y2, all divided by 2. All right, let's fill in what we know. M is, and here we go, x sub 1. Your first x-coordinate is right there, negative 10. And we'll add to that x2, your second x-coordinate, which is 12, all over 2. Comma. And here we go. Y sub 1, your first y coordinate, which is negative 3, and then plus negative 8. Well, rather than writing plus negative 8, I'm just going to write minus 8 all over 2. And let's see if we can't clean this up now. Negative 10 plus 12 sounds like it's going to be 2, still divided by 2. Negative 3 minus 8 is negative 11. That gets divided by 2 as well. So here we go, guys. This should finish it up. 2 divided by 2 is 1, and I was a little mean to you here. Negative 11, of course, is an odd number, which means it doesn't divide evenly by 2, but that is going to be negative 5.5 or negative 5.5. And that is the midpoint here of line segment XZ. And we call that midpoint Y, so those are the coordinates of point Y there. You just want to make sure, guys, that the X value you come up with right here, in this case 1, is in between this number and this number right here. Now, it should be exactly in the middle right there, but yeah, it is. And let me switch colors. You'd want to make sure that this y value right here is in between these two y values here, and it is. If I were to come up with an answer like, and I'm just making something up here, 20 comma negative 9, there's no way this answer can be right, because 20 is not in between negative 10 and 12. It's actually greater than both of them. And negative 9 is not between negative 3 and negative 8. It's actually less than both of them. So there's absolutely no way that answer could possibly be right if we were trying to find the midpoint between 2 points. Okay, I have a third example for you here with midpoints. This one, if you read carefully, though, is different than the two we just did. Let's take a look at what it's asking us to do here, guys. It says to find the coordinates of point Q if M is the midpoint of PQ, and they've given us the coordinates of P and M. So I think a diagram here might be a good idea, guys. We have a line segment right here, and they want us to find the coordinates of Q if M is the midpoint of the line segment PQ. So here's P, here's Q, and M is the midpoint located right here in the middle. Now, this is no different than what we just did on the last two problems. However, in the last two problems, you were given the coordinates of P and the coordinates of Q, the endpoints, and you were trying to find M. This one is flipped around a little bit. Now, you've been told the coordinates of P, 3, 7, and the coordinates of the midpoint M, 5, negative 1, and we now have to come up with the coordinates of point Q. And the midpoint formula that we wrote down, that we used on the last two problems, isn't really going to help us here because that's the formula for finding a midpoint. So we got to be a little bit crafty about the way we do this and try to approach it differently. Now, there is a lot of different ways of doing this problem. There are certainly more formal ways, but I'm going to show you guys a little hint here that I really like when you're trying to find a missing endpoint. What you're going to do is write the 3 points in order. Endpoint, P, then the midpoint, M, then the other endpoint, which is Q. But they've got to be in that order, guys. I guess the Q could go first, but M has to be in the middle because that's your midpoint. Now, let's write the coordinates that we know. P is the ordered pair 3, 7, and the midpoint, M, is the ordered pair 5, negative 1. We've got to figure out the coordinates of point Q. And how are we going to do that? Well, check it out, guys. All you have to do is follow patterns here. How do you get from 3 to 5? By adding 2. So now you're going to do the exact same thing here again. You're going to add 2 to the 5, and 5 plus 2 is going to get us 7 for our x coordinate there for point Q. Now we'll do the same thing over here with the y coordinates. How did we get from 7 to negative 1? That one's maybe a little bit tougher to see. We subtract 8. So we're going to do the exact same thing here again. Subtract 8. And negative 1 minus 8 is going to give us negative 9. And those are the coordinates then of point Q. So this concept right here, guys, of just repeated addition, here we had adding 2, add 2 again, and with the y coordinates, subtracting 8 again, that can save you some time and heartache on a problem like this. All right, guys, and I just have one more problem to do with you. I don't really know that it needs to be done because we've already talked about problems like this earlier in the chapter, but they reintroduce these problems here in 1.7 with a word. So they call these problems finding missing measures, and let's read our directions. Find the measure of JL if K is the midpoint of segment JL. So they wanted you to see this problem again, but now using the word midpoint. So if K is the midpoint, everybody, that means that K is equidistant from J and L. It also tells you that line segment JK has to be congruent to line segment KL. So I could do some tick marks right here and say that JK has to be congruent to KL. That's what the word midpoint means. And now this looks just like a problem that we solved in section 1.3, if I'm not mistaken. If these two line segments are congruent, that means that their measures have to be equal to each other. This quantity must be equal to this quantity. So there's our equation, guys. 4x minus 5 must be equal to 19 minus 2x. And how do I know those two pieces are congruent? Because they look the same? No, because the directions use the word midpoint. So there's your setup. Now it's just basic algebra. I always move the smaller variable term to the bigger one. Negative 2x is the smaller one. So I'm going to add a 2x on the right and the left. And if all of my variables are going left, I want all of my constants to go right. So I'm going to add a 5 on both sides of the equation as well. Okay, these 5's on the left cancel out. These 2x's on the right cancel out. 4x plus 2x is going to give us 6x. And on the right, 19 plus 5 is going to be 24. We are going to divide both sides by 6 here, and we're going to get our answer now for x. X is equal to 4. Now, it's always tempting when you solve for x to circle it and move on to the next problem. Let's read our directions again, though, guys. We're supposed to find the measure of JL. So let's use this new value of x equals 4. Let's figure out JK. 4 times 4 is going to be 16. 16 minus 5 is 11. So that's how long JK is. Now, KL had better be the same thing if they're congruent. If x is 4, 2 times 4 is 8, and 19 minus 8 is 11 also. But we were asked to find the measure of JL, which is the length of the entire piece. How are we going to do that? We're going to add the 11 and the 11 together and answer the question now. JL is equal to the sum of 11 and 11. JL is equal to 22, and that would be the actual answer to this problem right here. So it's true in every class, in every level of math, but it's especially true in geometry, guys. When you think you're done, which again we often do when we know what x is, make sure you go back and read your directions and make sure you have answered the question that is being asked. Yes, it's true that x is equal to 4. They wanted to know, though, for the final answer, the measure of segment JL, and so 22 is our correct answer. All right, guys, that's everything we have there for section 1.7 on midpoints and bisectors. So let's give that homework a try. Let us know when you guys have questions.